What's going on, everybody? Welcome to CS540 final review. So if you're new here, but hopefully it's not your first time here, but if you're new here, be sure to check nearlyblog.com and click this page, and you are able to see this page. So I would strongly encourage you guys to watch the YouTube videos. So as you can see, all these videos are actually just like around 10 to 30 minutes, and it covers nearly all knowledge in that topic. And I would say, well, it's absolutely enough for you to deal with the final questions. So I would strongly encourage you guys to watch these videos just for review purpose. So let's just jump into our final. So this is the 2017 fall final exams. Yeah, so let's look at the first question. So the first question is talk about the Zipf's law. So for the Zipf's law, there is a really important equation. That is, the frequency appears that the frequency about a word in a vocabulary times its ranking is somehow, actually here should be somehow equals to a constant c. And the question asks for the word W1 is third rank. So as you can see here, if we move the R to the C side, so we just divide C by 3, and for word 2, you just divide by 7. So for F1 divided by F2, the frequency, which is just 7/3. So this question is pretty straightforward. So for the second question, there are actually few pose. So first is Alice. So let's say here is just 2. Bob's is at 4th. And Cindy is at the 9th. Oops. And the pose can just be, if I remember, at the even spaced. So you can just be 2, 4, 6, etc. So the question asks, what should the school set up a school bus stop so that the sum of distances walked by the 3 students is minimized. So first, let's see what's the possible solutions. So first stop can be here, 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 and after 9. However, for case 1 and case 4, it's actually the maximum distance, since all the students need to go from their own place and to that place. So the first and fourth place, we can just ignore that. And if we put at the second place, which is any place here, so the distance summed up by the A and B, their distance is just a fixed number, which is 2 here, and here also here should be 5. And the student C needs to walk all the way here, which is, for example, here the distance between the stop and B here is x. So what C need to walk is x plus 5. And here is 2 plus x plus 5, which is x plus 7. And the same way here, the 5 here is a fixed number, and let's suppose the bus stop is here, then this distance is y, then what A need to walk is 2 plus y, which is still x plus 7. So as we can tell from these 2 equations, that the minimum distance sum up is when x equals to 0, and when x or y, sorry, here should be y, and when x or y equals to 0 is actually at the B point, And since b is 4 and this is an even number, so it satisfies the question, so that is fourth. What by 3 reducing? So it's the median. Yeah, so the fourth pool. And for the third question, it says, okay, so what's the probability for this one? Well, so let's say b equals to y. By given the condition of rainy, both not rainy and not warm, so it asks you to calculate this. So we can just transform by putting the sign back, which is b equals to y. It's rainy and it's warm. It's not warm. However, we need to do some adjustment here. So first of all, we need to time PW is n is not running and divide by this stuff. So what we can tell from this, from the formula here, is actually it equals to 0. So by given it is not warm, we can actually find these 4 cases. And if the bighorn didn't see they see the bighorn, then there are 2 cases here. One is here, the other is here, and it also asks that it's not rainy. So not rainy only have this condition. So here is 0. So this is just 0, and we even no need to calculate this part and this part, and we can just conclude that it is 0. This is third question. For the fourth question, it says so these are the 2 states, and the reward. So you can either move right or move left, and the reward from S1 to S2 is 1, and from S2 to S1 is 0. So there is no reward. And it also says about the discounting factor, which is gamma, and it asks you the value function of S2. So what it says is actually you just start from S2 and calculate the value at S2. So every time S2, when S2 moves to S1, from state S2 to state S1, it actually has no reward. However, you can still from S1 move back, which is from S1 to S2, and you're able to get reward. So what the optimum policy is, you just continuously moving, all right? So you just move, and your value can just increase over time. So actually, the answer here listed here. So at the very beginning, since when you move from S2 to S1, you have 0 rewards, so you times here is 0. And from S1 to S2, you have gamma, and your reward is 1, so you just time 1 here. And when you move, when the second round, here is just 0, and here is just 1, so on and so forth. So if you simplify this formula, is gamma plus gamma square plus gamma cube plus, and I would just, sorry, my bad, here is not 2, here's 3. Here's cube, and here is fifth. So how can we simplify it? We can assume last stuff is 2n minus 1. So that is when n equals to 1, then this is 1. So here actually you can assume that here is 1. And if n equals to 2, then here is actually 3. So we can actually translate that. so which is 1 minus, since each of them times gamma squared, and the first term is gamma, and 1 minus gamma squared, and here should be n. And just change it back. So wait, minus 2 should be this equation. And since the gamma is actually somehow smaller than 1 here, and when n goes to infinity, this term actually equals to 0. Which is to say, this term will goes to 0 as well when n goes to infinity. So we can conclude that this term will just goes to 0, and we just simplify that. So we just leave the other term, which is this one. So answer is this one. The fifth question is about Q-learning, but since we are not touching the Q-learning question in our final this year, so I just jump this question. The sixth question. So there are two. I think we have done this question a couple of times. So we have two group of piles. So each of them has 2 sticks. And each time you can either take one or take one from both piles if you can do that. So here's the first player, which on the other hand is to say that here's the max function here. So first of all, you can take one from each 2 piles, or you can just take one from 1 pile. Here's the second player, so he can take both of them, and the second player will win in this time, so the result is -1, or he can just take one. So here you can just take one, or take 2, or take one from each pile, which is only 1 left here. And here is just wins, the first player wins. Here you can take either one, yeah, this is the only choice, and here is as win, and here is the lose, the first player lose. So here is max function, here is min, and this line is max as well, and here's min. So when we go back to our line here, so this time it only has -1. And for this line, since it is still just taking them, which is -1, and here's 1. However, here it is taking the minimized value. So first of all, for this pile, it will take the minimized value as here, so which is -1. And for this pile, it will take the minimized value here, and it's also -1. And for the first player, it takes the maximized value between 2 -1. So it can only, the only choice for them, for the first player, is just -1. So the first player will lose the game. So this is question for this is solution for question 6. Okay, so we use the gradient design to find a minimum of the function with a step size of, how to say this, gamma. If we start from the point 0, x0 equals to 3, how more should this, so we can make the progress. Okay, so when we talking about making the progress, is we just want to find the minimum, either the local or the global. Of course, we're always finding the global minimum, but probably we might find the local minimum, but that is fine. So every time, for example, a function just like fx equals to x squared, what we always want to find is this point 0, 0. We always want to go to this point. However, when we are at other points with a gradient design, we might go back. This is what we call overtrend. So that is, you actually go, if your stop is really large, you actually, so this is what we hope to see. So it goes to here, 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 and continuously, and you might come to the origin point. However, in that case, in the blue case, in the yellow case, it will actually go out of that, and you cannot make any progress from it. So this question, it says that the gradient descent. So we can just get, so gradient descent is, this is the updated x, so it will equals to the previous x minus this is a derivative of function and times what we call, this term is the learning rate. So here is 3, and here should be, so if we take the derivative for this term, is actually 2x. However, since x is at the x0 equals to 3, so it should be times 3. So just let you make it more clear. So when x here equals to 3, and here's the gamma. Okay, so since at the beginning point here we are actually at 3, 9, so the x value for it is 3. So we don't want to make this case, so we just want to make it lower. And in order to make it lower, we just want x. So here, if symmetric, if we do the symmetric line here, here is actually minus 3. So we want it to be larger than minus 3. Since gamma here is a positive value, so we this term definitely will be smaller than 3. But here we just want it to be larger than 3. So if we do some, which is 6 gamma smaller than 6, so gamma is smaller than 1. We now need to put the gamma greater than 0, since we would assume that the gamma is greater than 0. So this is question 4, solution for question 7. For question 8, okay, so given the knowledge base, which are 2 sentences here, use the resolution to prove the query Q. Okay, so from A, what we can get is actually this one. Oops, here should be an and. When we transform it, so we can actually get this term. Oops, here should be a or, my bad. So if we focus on the question here, it actually give you a P here. So what it asks you to do is it just want to give you an P and ask you for the Q. So sorry, here should be a Q. So if you notice that we can use both of terms, and you can, if you remember, the AND elimination is when this term equals to true, then both terms of the AND should be true. However, if we just use the latter part, since this is true, and we already know that P is true here, so no matter Q equals to true or false, this term will still be true. So the latter term is not useful. So what we're going to do is we just get the first term, and for this step to this step we have the AND elimination. And since here the P is true here, so this term is actually false. And in order to make this term to be true, then Q equals to true. So we prove that. And for the formation of our answer, actually I won't write like that. So this would be my step. If in the real exam, I would do like this. Here's P and here's Q. So I will just list down these second, third, and fourth stops in the exam, and I believe this is correct answer. So for the ninth question, so the translation for the for door has exactly one ring. Okay, so this question is a little bit tricky. So as we remember in the previous videos, actually make if we have a if then sign, then we should always associate it with and if we have a further description, and if we have or, then we have to have this. Sorry, have the if and sign here. Sorry, this is not if and sign. This is just there is or there exists meaning. All right. So by using this stuff, we can actually give up the choice C, since the sign here should not use the if then, and meanwhile we also can give up A, since A here the logic is kind of math. So it's like, okay, so in order to make this question clear, I will just draw some rings here. All right, so let's suppose the Florida got these 4 rings. So what A actually is saying is there is a ring A, a ring X, and which belongs to Florida, and there is a ring Y which belongs to Florida. Then these 2 rings are the same. But for Florida itself, he can have 4 rings, and the X and Y are just the same ring. For example, here's A, and both rings are just A. So the A satisfies, but it doesn't say that Florida has exactly 1 ring. So for the choice B here is actually saying that for all the rings that belongs to Florida, it can interpret that there is a ring belongs to Florida, and this ring is just the same as the last ring. So this actually doesn't make sense. That is still because like you can have these 4 rings together, and X is just, for example, one of them, and you just derive them a Y which is the same as A here. Then you can say, okay, this Y is same as X. Actually, this doesn't make any sense. It's hard to interpret. I mean, it's just out of logic. But if we look at the D here, which is there exists the ring X, which belongs to Florida. So yeah, there is a ring, but here is some of the rings, not all of the rings. And for any other kind of rings belong to Florida, then this ring is just the last ring, which meaning this ring is just exact 1 ring, since for no matter what kind of rings the Florida has, it's just the same as this ring. So this is only 1 ring that Florida has. So yeah, so just like to understand it by yourself, it's a little bit hard for me to interpret it deeply. This is what I can do best. So for the 10th question, you have a PCA in a 3rd-dimensional place. So the first component, first principal component is U1, and the second is U2, and you have a point on X, which is 1, 2, and 3. So what's the new presentation to be? So as we mentioned in the previous videos, the PCA, one of the usage of PCA is just to transform a vector into a multi-dimensional, into a 2-dimensional panel. So what we can do is just first we just use U1 to times X, but here of course we need to have a transform function. That is 1 times 1 over square root 2 plus 2 times 1 square over 2 and 0.3. So if we add them together, we can actually get this term here. And for the Y term is exactly the same. So this question is pretty simple. So for the 11th question, which is about linear regression, this question is very interesting. So it says, previously it thought that the y here is the label and the xd here is just the dth dimension of the input. However, later it says, okay, I just swap them. So here what it says is y is the dth dimension input and xd here is the label. So it asks how can you like to transform the function? How can you by giving the x data inputs, how can you get the label? So this is very simple, I think. So we just need to take the forms in the right hand side and to the left hand side and divide by the beta d, then that's it. This, I just have no idea what this question is about, so and for the 12th question, it says a star search. So at the moment that A declares a success, so when A goes to G, it actually declares, so G is the go state. And you can only perform left, right, up, or down the movement. And also the cost G here is actually the number of movement take. So by performing a star search, we can know, so the heuristic value here should be 1, since it only needs 1 to get G here. So A has 2 children, one is G, the other is B. The heuristic value for G is 0 and for B is 2. Since for B you need to move from C to G or from A to G, both of that will take 2 steps. So at the very beginning, the open is A, and we have 1 here. Then we delete A. Oh, sorry. We first have B, G, and B here. Then we just delete A. Oh, what I'm doing? Delete A. Then we have both G and B here. However, G also has G is our goal here. So what we're going to do is we just delete G in our open list, and the only thing left is B. So we can just put B. We no need to put. I think we no need to put. Oh, here should 1 plus 2, since we also need to count this here and the same as here. I just forgot the cost here. Yeah, this is correct. And why A here only has heuristic value is A is a start node, so there is no cost function for any cost for node A. So we can just leave the B here. So this is question 12. So for question 13, so it's a searching question. So every node, it has 3 nodes, and this is the relation, and it asks how many short paths are there from the initial state 1 to the goal state 540. So first, if it is 1, then it can be 3, 4, and 5. If it's 2, then this is 6, 7, and 8. And here we just do the something, 9, 10, 11, here is 15, 16, 19, so on and so forth. So we're actually just asking if we start from 1, whether we can find 540 or not. So as you can see here, here is 2 times, so there are only 2 nodes at the first level, which is 2 times, we can just put 3 to the 0, and for the second level we can put 2 times 3 to 1, and for the third level it's just like this. So we can find that. So for, let's say, for the nth level, so how many nodes we have? So 2 times 1 minus 3, 1 minus 3 to the, so here should be n plus 1. If here is n, then here's n plus 1. So here should be this one minus 1. And we found that we know that 3 to the power 5 should be 243, and 2 to the power 6 will be more than 700. So for the fourth level, 2 times 3 to the power 4, actually all the nodes added together, we have already have this amount of numbers. So for the fifth level, the beginning node should be 243, and there are 243 numbers in the node A. So if we plus 243, which is 486. However, since our number is at 540, so that node should belong to this tree instead of the first tree. So we cannot find the state 540 from the first tree. So that is for this question 13. And for question 14, so it's just a tree that so here is S1, for example. So let's say here is S1, then it has B children. I think, yeah, it has B children. So for each, let's say, so these are just all the children here. And the best, it says the luckiest case. So for the iterative deepening search, it's also a transformation of DFS. So the best way should be just like this. So the goal node should be right after the first node here. So it asks how many times the goal check will be performed by using the iterative deepening search in the luckiest case. So at the very beginning, it will just search S1 when the depth is equal to 0, and when depth equals to 2, oh sorry, here should not be S1, which it only checks 1, which is S1 node, and the second time it will check 1 plus B times, since it will check the S1 one time and check all its B children. And for the third time, it will only check 3, since that is S1 and the first children, let's say is A, then to the go. So there are only 3 checking, which is 5 plus B. That is the solution for question 14. And for question 15, this is a gradient descent question. So here is a vector x, and it gives you fx, this correlation. And if we start at all 0 vector, all is 0, so what's the next vector? x1. Okay, so this question is similar to the question we saw before. So here, the new x is just by using the gradient descent, the new x vector is actually the previous vector minus the derivative of fx times the learning rate here. So the fx, if we divide it every time, so so here is fx, and if we divide by x1, it actually is 0, and if we divide by x2, then it's 2. So the vector form for the derivative of fs is this one, and we know that the learning rate is 0.1, so we can just, and here is 0, so we can just put the 0.1 times 1 to blah 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 d, and we can get this, which is the updated vector. So for the question 16. So I will just use an alternative method to solve this question. Sorry, it's the same. Yeah, I think I just like illustrate from here. So for the first equation to here, you just we need to cancel the if and sign here since we are going to get the CNF. So if and sign is just we take the negation value out for the first parameter and or the second parameter. So the same for the latter part. And by doing this, is the same. We have the negation sign and or the latter part, and we just put it in. And just remember, if we have negation, we need to transform from either or to and, or to and to or. So as you can see here, it actually changed from or to and. So after we get this, however, you remember for the CNF, we can just have the and sign between different item. So what we got into here is we just times this and sign with or sign. So we can just p time p or this term and my negation q or this term. However, we have two negation q, so we can just have one of them here. So this is question 16. For question 17, it's one-dimensional space and is clustering here. Also hierarchical clustering with complete linkage. Pay attention, is complete linkage. And okay, so first of all, the first step is 1 and 0. So here is just 1. So I personally in the exam I will just draw like this. And the second part, if you see, since A is complete linkage, so for C to A and B here is actually 3 minus 0 instead of 3 minus 1. So here the distance is 3. However, for D and E here is just 2. So we will do D and E first. Then we are going to do this and go to this. So just to let you know, so here the distance from C to A and B here is actually 3. And how about from D and E to ABC? So this distance is actually 9, which is the largest distance because of the complete linkage, which is to use 9 minus 0. This is question 17. For question 18, well, I really have no idea what this question asking about, but it's just extremely easy. I just don't know why. And I cannot find any relationship between this question and K and N, to be honest. 1, 2, and until xn. So xn, and here is x plus 1, xn plus 1. So it says what's the value for this one. So here xn should also equals to n. So it says, okay, what's the value for xn plus 1? So the 3 neighbors of xn doesn't have xn plus 1, but the 3 neighbors of xn plus 1 has xn. And it's pretty simple. It's just like this, minus 3. So the 3 neighbor of xn should be this 3, and in order for xn to choose 3 of them is xn plus 1 much larger than n plus 3. Since if xn plus 1 is smaller than n plus 3, then xn will choose this term instead of n minus 3. And I think this is the correct answer. And if you include the neighbor xn itself, you can also put like this, but I would just put xn plus 1 is greater than n plus 3 in exam. The 9th question, okay, so it is just purely talking about neural networks. So everything is linear. So as you can see here, we use a linear combination of all the inputs to the units. So what kind of function can this network compute? Of course, if you just have the linear, so this is a neuron, and this inside is its activation function. For example, just like fx equals to x here. So you can only output the linear function. You cannot make any other functions at all. So this question is really straightforward. For question 20, so it has 2 points and the head, okay, A and B, coins A and B, and their probability with their head. So what's the probability that I took one coin at random and flipped once, the outcome was head? Okay, so by given the condition of head, what's the probability that it was coin A? So we can just transform this formula to this one, and we're going to time PA and divide by PH. So if we got coin A and the head should be 0.1 here, and the probability of getting a point on coin A is 0.5, since you just took the coin at random. And to get the head, so first you have 50% of chance to get a coin A, and you get the probability you get a head is 0.1, and you got another 50 chance to get a coin B, and the probability is 0.8, which is 1/9. Yep. So this is the answer for question 20. And for question 21, oh man, this is just like, this question is just so interesting. You try a binary classifier on training set and tested its performance on separate test sets. Your classifier was wrong on every test item. You're very happy. Why? Well, you can just say like this. You just like negate. So if you have a if it outputs a 0, then the actual value is 1. But and if it outputs a 1, the label should be 0 in the testing set. So you just flip that, then that's it. Well, however, I think in the real case, if you train a classifier like this, you have to first make sure that your label is correct, all right? You don't be that happy. You just negate that. Don't do that. You have to check the label. But there's one thing. If you check your label is correct and you happen to just all the stuff are just the opposite when you are training the binary classifier, then you should be sad. You shouldn't be happy since you are completely wrong, right? But I know this question, yeah, just be smart in the question. So consider 4 points here and 2 centers, and this is a k-min after iterations of k-min. So it's just talking about the first iteration. So there are 4 points here, and x1 to x4, and here is c1, and here is c2. So we can just connect the dots here, and we can just make a perpendicular line, and this is the middle point from c1 to c2. So you can see here actually the 4 points, all the 4 points here actually in the c1 range. So when calculating the center, so c1 will move to the middle, so which is half and half. However, for c2 there is no points in this area, so it won't do any changes to this the location of c2. But you have to clear that given condition that if there is no point in that area, then that point, the cluster centers won't change. So for question 23, consider rectified linear unit. The output, okay, write down the inputs, value x that produce. And this question, I believe, is also very simple for you guys. So in order to make y greater than 0, then the only thing we need to make sure that is this one is greater than 0. And we can just divide in different conditions, then we can just get the solution. So for question 24, it's also a question that turns out a lot of times. So this is S1, so it has two children, S0 and S2. S2 the same, S3, blah blah blah, until it goes to Sn minus 1. Here's Sn, and here S0, and here is Sn. So they ask you how many times you will check by using the BFS and also iterative deepening search method. So by using BFS, we can know from S1 to Sn minus 1, here is n minus 1 term, and each of term will check 2 times, which is the current term and also S0 and another children. So for BFS, it's just 2 times n minus 1 and plus the Sn term, which is 1. So 2n minus 1. For iterative deepening search method, every time, so for the first term, it will check 1, and which is d equals to 1. And when d equals to 2, it will check 3. So you could say 2 times 1 plus 1 plus. So for the n minus 1 term, it will check 2 times n minus 2 plus 1. And it also has the Sn term. Well, here, just move it back to here. Minus 2 plus 1 and plus 2 times n minus 1 plus 1. So you just add all of them together, then you're able to get. So it's 1 plus 3 plus 2m minus 1. So this is the last term here. And to calculate this term, and we are able to get n squared. So for question 25, it's kind of tricky. So both h1 and h2 are the heuristic functions. So it asks what should the alpha value be in order to make this term to be admissible as well. So this term should greater or larger or greater than 0, while it should both smaller or equal to h1 and smaller to equal to h2, since we don't know the value for h1 and h2, alright? So I think the best way to do this question is to draw a graph. So here the x-axis is alpha, and if we take this term to the f alpha, then the vertical axis should be the value of function of alpha. So when alpha equals to 0, then the value is actually h1, and this is satisfies. So first, a condition, let's say h1 minus h2 is greater than 0. So if this is greater than 0, when alpha increase, then this value, the whole term f alpha here, will actually decrease. So for the first condition, that is when alpha, which is like this. So this is a function, and here the value when hits 0, then alpha equals to h1. I think I need to change color, it's not clear. H1 over h1 minus h2, which is the point here, and this is its function when h1 minus h2 is greater than 0. And for the second condition, that is h1 minus h2 smaller than 0. If it's smaller than 0, then this when alpha increase, the f alpha value will increase as well. So it will be like this. And here should still be h1 over h1 minus h2. Pay attention, since here the h1 minus h2 is smaller than 0, so it's actually at a negative part of the alpha. So as we can see, we want to make it both larger than 0 and also smaller or equal to both h1 and h2. So for the first case, h1 is greater than h2. So when alpha equals to 0 is actually h2. So in this case, what alpha can be is from 0 to h1 minus h2. Since all the portion here the value is from 0 to h1 and it satisfies this part. However, if we go up here, we cannot make sure whether that's admissible or not. The same thing if we goes beyond this point, then it's actually smaller than 0, and that doesn't satisfy. And for the second part, this part is also good. However, it can still be 1 here. That is when alpha equals to 1, then here is h2, since h2 is greater than h1 in this case. And the value should be h1 over h1 minus h2 to 1. Actually, there is a third case. The third case is h1 minus h2 equals to 0. If both h1 and h2 are equal to each other, actually the alpha can be anything. If we combine these three stuff together, we can just take this part, and we are able to get this. And the reason is pretty simple. This term is negative, so when get the minimized value, we have to take the largest one, which is 0, since 0 always greater than the negative value. And for this one is actually greater than h1 over h1, and which is equals to 1, since h1 minus h2 should be a value greater than 0, so it will greater than h1 and this will greater than 1. And when taking the maximized value, we need to take the smallest value, which is 1 here. So the value should be x on 1. I think this is the end for the final review. If you have any questions, concerns, please feel free to leave it below. Because of my time issue, I cannot make other final review on other different years paper, but I will definitely help you in the Piazza. So if I have time, I'll look at Piazza and help you as far as I can. Meanwhile, I just want to say to you guys, thank you so much for support for this semester. Actually, I'm an exchange student only this semester. I really enjoy the CS540, this course, and also really enjoy to have this class with you together. So it's my great honor to meet you guys. I'm from another corner of the world, and just thank you so much for your support. I really hope this tutorial series is helpful to you. So if you have any questions, please feel free to leave it below. And if you have any suggestions, comments, you can also tell me so I can improve my videos in in my later life probably. Alright, so lastly, I wish all my best to your final, and thank you very much for watching.